So we have f of x being equal to the absolute value of x plus 2. And we want to evaluate the definite integral from -4 to 0 of f of x dx. And like always, pause this video and see if you could work through this. Now when you first do this, you might stumble around a little bit, because how do you take the antiderivative of an absolute value function? And the key here is one way to approach it is to rewrite f of x without the absolute value, and we can do that by rewriting it as a piecewise function. And the way I'm going to do it, I'm going to think about intervals where whatever we take inside the absolute value is going to be positive, and other intervals where everything that we take inside the absolute value is going to be negative. And the point at which we change is where x plus 2 is equal to 0 or x is equal to -2. So let's just think about the intervals x is less than -2 and x is greater than or equal to -2. And this could have been less than or equal, in which case this would have been greater than. Either way, it would have been equal to this absolute value. This is a continuous function here. And so let's do the easier case. When x is greater than or equal to -2, then x plus 2 is going to be positive, or it's going to be greater than or equal to 0. And so the absolute value of it is just going to be x plus 2. So it's going to be x plus 2 when x is greater than or equal to -2. And what about when x is less than -2? Well, when x is less than -2, x plus 2 is going to be negative. And then if you take the absolute value of a negative number, you're going to take the opposite of it. So this is going to be negative x plus 2. And to really help grok this, because frankly this is the hardest part of what we're doing, and really this is more algebra than calculus, let me draw the absolute value function to make this clear. So that is my x-axis, that is my y-axis, and let's say we're here at -2. And so when we are less than -2, when x is less than -2, my graph is going to look like this. It is going to look something, let's see, it's going to look like that. And when we are greater than -2, we do that in a different color. When we are greater than -2, it's going to look like this. It's going to look like that. And so notice, this is in blue, this is the graph x plus 2. We could say this is the graph of y equals x plus 2. And what we have in magenta right over here, this is the graph of -x minus 2. It has a negative slope, and we intercept the y-axis at -2. So it makes sense. There's multiple ways that you could reason through this. Now, once we break it up, then we can break up the integral. We could say that what we wrote here, this is equal to the integral from -4 to -4 to -2 of f of x, which is in that case, it's going to be -x minus 2. I just distributed the negative sign there, dx, and then plus the definite integral going from -2 to 0 of x plus 2 dx. And just to make sure we know what we're doing here, if this is -4 right over here, this is 0, that first integral is going to give us this area right over here. What's the area under the curve -x minus 2, under that curve or under that line and above the x-axis? And the second integral is going to give us this area right over here between x plus 2 and the x-axis, going from -2 to 0. And so let's evaluate each of these, and you might even be able to just evaluate these with a little bit of triangle areas, but let's just do this analytically or algebraically. And so what's the antiderivative of -x? Well, that's -x squared over 2, and then we have the -2, so the antiderivative is -2x. We're going to evaluate that at -2 and -4. And so that part is going to be what? -2 squared. So it's the negative of -2 squared. So it's -4 over 2 minus 2 times -2. So plus 4. So that's it evaluated at -2. And then minus, if we evaluated it at -4, so we're going to have -4 squared is 16 over 2 minus 2 times negative 4. So that is plus 8. So what is that? What is that going to give us? So this is negative 2. This right over here is negative 8. So the second term right over here is just going to be equal to 0. Did I do that right? Yeah, the 16 over 2, it's negative, and it's positive. Okay, so this is just going to be 0. And this is negative 2 plus 4, which is going to be equal to 2. So what we have here in magenta is equal to 2. And what we have here in blue, well, let's see. This is the antiderivative of x squared over 2 plus 2x. We're going to evaluate it at 0 and negative 2. You evaluate this thing at 0, it's just going to be 0. And from that, you're going to subtract negative 2 squared over 2. That is positive 4 over 2, which is positive 2. And then plus 2 times negative 2. So minus 4. And so this is going to be the negative of negative 2 or positive 2. So it's 2 plus 2. And that makes sense. That what we have in magenta here is 2. And what we have over here is 2. There's a symmetry here. There is a symmetry here. And so you add them all together, and you get our integral is going to be equal to 4. And once again, just as a reality check, you could say, look, the height here is 2. The width, the base here is 2. 2 times 1/2 is indeed equal to 2. Same thing over here. So that's the more geometric argument for why that area is 2, that area is 2. Add them together, you get positive 4.